Okay, so let's move on to the valuation modeling itself then. I'm going to go back here to without adjustments. So I doubt you've got a lot of question with respect to how you apply this for FCF or how you apply this for KVD. You had to do these applications a couple of times in the problem set, right? At different discount rates. Remember that this continuing value is the only place where we see a difference between these two models. It's the only place we see a difference. Let me see, who do I want to pick on? Carol, I'm going to pick on you for a minute. And you can get help from any one of your friends if you might like, whether you ask for it or not, okay? So when I tell you that we have a continuing value as of year 5, what does that continuing value represent? Any idea?
The value of growth.
Say that again, please.
Are you measuring the continued growth?
Well, yes. Growth of what?
Cash flows.
The cash flows.
Cash flows, yeah.
That's exactly right. And does this continuing value, does it pick up any elements from before 2025? Or does it only pick up the cash flow starting in 2025 and then move forward?
Previous to, right?
Yeah, it doesn't pick up anything previous. It uses the Gordon growth construction and then takes that number, which is the first cash flow past the explicit period, and then divides them by WACC minus G. Is it accurate to say that this continuing value picks up all future cash flows, including this one, from this point forward?
Yes.
It is, isn't it? That's what the Gordon growth model does. In fact, it picks up all of them. Every one of them that could ever possibly be in perpetuity. Well, how did I say we value a company or an asset? The value of an asset is the present value of all expected future cash flows, discounted for rate and time, right? So this continuing value, which remember is CV0 equals FCF1 divided by R minus G, right? So since it's CV0, it's a value as of, in this case, year 5, because that's year 0 if year 6 is year 1, right? So is it fair to say that if we were looking at this company as of the end of 2024, and we were applying a 2.5% growth rate to its future cash flows, that the value of the company at that point in time would be 1,131.45? Is that what the continuing value is telling me? What do you think, Mario?
Yeah, that's what it's telling us at that moment.
What it's telling you?
At year 6. But that's why we look for the present value, right?
Yeah, so we're now, because we're not looking at it in 2024, we're looking at it now, right? And so we're going to have to discount it back to today. But if we were looking at this as of the end of 2024, we would be saying that its value at that point in time, all expected future cash flows, based upon a 2.5% growth rate in this case, divided by a discount rate minus that growth rate, gives us a value of 1131. The continuing value is the present value at that point in time. It is the estimated value at that point in time. So what we're doing is we're finding all the cash flows between now and then that we get to enjoy, discounting them and adding them up. And then we're finding all the possible future cash flows and discounting and adding them up and bringing it all back to the present in this present value. So if instead of calculating this using the Gordon growth model, if I said, I believe that we could sell the company here at the end of 2024 for a number that's, let's say, 5.6 times its EBIT. I just believe that at the end of 2024, we could sell it for 5.6 times its EBIT. We'd figure out what its EBIT is going to be in 2024. I think that's EBIT, isn't it? Yep. And we'd multiply that by 5.6, right? And that's very similar to the example I gave you in a question that you had in one of the various homeworks. I can't remember if it was a practice homework, or problem set. But you'll remember having seen that. Kind of keep that in the back of your head, because that's where we're going to circle back around to after we talk just a little bit further about FCF, KVD, and our buddy, the adjusted present value model. Any questions about what I was just saying with respect to continuing value? Kate, let's assume for a minute that this isn't a full company, that this is a fleet of trucks that we are buying for our company, and we believe we're going to use and abuse them such that at the end of 5 years from now, they'll have a scrap or a salvage value, but not a lot more useful life. That salvage value, would it be the value of the trucks at that point in time?
Yes.
Yeah, I agree.
CV.
I agree. We would substitute it for a CV. Or maybe I bought David's company. And David knew I was a little nervous about doing this. You know, it's got some real promise, but I've been a little bit concerned about some things happening in the market. And David said, don't worry about it, Rick. I will agree. At the very least, I will buy it back from you in 5 years at 1,000. I could use that contracted value as my continuing value, couldn't I? At the very least, Dave is going to buy it from me at that 1,000. So this continuing value represents something meaningful. We have bounced up against this several times in our weeks together without me defining it for you as clearly as I just did. And you may or may not appreciate that, but it's purposeful. I wanted you to understand its various forms of calculation. I wanted to embed for you some of the forms of calculation and using it before we had to think from just a theoretical standpoint what it might mean, because it is kind of abstract. Okay? Bella's not sure she agrees. She's just kind of listening for a few minutes, right, Bella? It's okay. All right, so my guess is you understand how I got FCF's model, and you understand how I get the KVD model. Any questions about how I now apply the adjusted present value model? Bella, I'll let you come off of mute. How does the adjusted present value model differ from the free cash flow model?
It has the different forecast ratios, like the adjusted forecast ratios that are being taken into place.
Well, no, not yet, because notice here I'm still in this one worksheet and I'm not looking at the adjustments. So not really. Taylor, any idea how this might differ?
I just remember vaguely that instead of WACC, we're using like the cost of unlevered capital.
So we do use different discount rates. We must. Otherwise, we're going to end up with a value that diverges from the value we got in the other model forms, and it'll do so in a significant way. And we know theoretically that ought not be the case, because an orange is worth whatever an orange is worth, regardless of which direction you look at the orange from, right? Okay, so the discount rates are going to have to differ. There's something else that's critical here. Andrew, do you recall the biggest difference between the APV model and these other two?
No, I don't.
Okay.
It uses a tax shield.
Yeah, but uses it for what, Kate?
Giving you more money or more cash flows.
It's a cash flow. Now, in this case, it's a cash flow brought about by having saved something, right? We saved some money on taxes. Well, as I said when we first introduced this, I don't care if I end up with an extra dollar in my account because I got an extra dollar of revenue, or if I saved a dollar of expense. Matters not to me. I care I got an extra dollar. Okay, so we're bringing into play two separate elements of cash flow. We look at the free cash flow, which is no different than our look at the free cash flow anywhere else, other than we apply a different discount rate. And then we estimate the tax shield. And the tax shield is the interest expense that is there because of long-term debt, right? The interest expense, it's tax deductible. So when we have interest expense, it lowers our tax liability. It gives us a cash flow that is from savings. It's called a tax shield because interest expense shields us from paying more in the way of taxes. So we have two cash flows. And if something with one cash flow gives us a value, if we add another cash flow to it, it ought to be also measured into its value. That's the main difference in the APV model for you. Now, yes, we have to use some different discount rates. I'm not going to spend much time, I'm not going to spend any time at this point talking about why those discount rates are different or how you would find them, other than telling you that normally what you will do is the opportunity cost of tax, or K-tax, will be similar to current yield on our debt. And then this KU, or this unlevered cost of capital, which is literally never observable, is estimated. And you don't need to know anything about it other than that. Okay, if you want to delve more deeply into it at some point, I'm happy to take you there. It just gets a little bit more convoluted. And my recollection is y'all aren't that excited about convoluted. I can tell I look on Taylor and Kate's face, not so much with the convoluted. Okay.
I was going to ask that question actually, but it sounds like in summation, the most important thing is just that for the first half of APV, you're using the KU as your discount rate. On the tax shield, you're using the interest expense times the tax rate for your cash flow, and you're using the K-tax as your discount rate.
Yes. Yes. And you should end up with a number really very close to the present value on all of these. Because I go from 601, 599.9, 603, 601. They're all really very similar numbers, right? Okay. Any question about where we are at the moment? Kylie, could you motivate an adjusted present value model if you were given KU and K-tax as discount rates, if you knew what those numbers were?
I think I could if I had a model to reference. I don't think I could do it out of the blue, but I could maybe.
Okay. And I think more highly of you than you do, apparently, because I think you could. Because I want you to come back to looking at what it is we're doing. I'm in the quick sheet now, right? Mm-hmm. And I'm saying that the value using the adjusted present value model is simply the value we get from some free cash flow plus the value we get from some tax shield. That's all it is. We're adding up the two cash flows adjusted appropriately for their respective discount rates and time. That's all we're doing. And the first one, so VFCF, is right here. So you know VFCF already. You've been using the free cash flow model for weeks now. Oh, you've used WACC as the discount rate, or you've used the investor return as the discount rate. Fine. It's just a different discount rate. And VTax is simply the value of the tax shield as a cash flow using K-tax as the discount rate. And you're right, K-tax should be approximately the current yield on the kind of debt the company should be able to attract. Okay? And that's actually pretty straightforward. Now I will tell you, back when I was able to teach this class in a live setting, the first night of class, I would come in and I would write this beast up on the board. And I'd make it about as big as I could. And I would wrap that all the way across that board and say, okay, here's where we're starting. Does anybody not understand how to start from here? And I wouldn't do this with the MBA classes, by the way, because you guys are adult enough and fierce enough that sometimes I was afraid for my life. I would only do it with undergrads, okay? But this is a daunting equation, but not really. It's just the free cash flow model extended with another cash flow. That's all it is. So there's no reason to be intimidated by it. You guys have seen this over and over again. Michael, that's a cute baby brother. Good for you.
Yeah, she's a slight distraction now, so I apologize.
You know, and will be for about the next 32 years. So
Yeah,
just get used to it. Yeah.
I had my camera off for a little while because I was dealing with her. Sorry.
It's all good.
I am listening now.
Yeah, no problem at all. Okay, any questions you'd like to ask about the utility of these models, free cash flow, KVD, and APV?
Rick,
Yeah.
so for this model, are we pretty much putting aside the WACC?
In this model, we put aside WACC. Exactly. In fact, if we used WACC for the discount rate, both in the FCF part and in the tax shield part, we would end up overvaluing the asset, wouldn't we? Let me show you what happens. In fact, you're going to be encouraged to use WACC instead of KU and K-tax in another problem set so you can show yourself how distorted things get. But let's just go ahead and look at this for a minute. I've got a WACC of 14.47 and it's running for me a value of about 600, right? And I've got my KU and K-tax at 15.5 and 4.75 respectively to get to that same 600. If these were both the same as WACC, then we would end up with a much different value. Would be about 612, not 600. And you might think, oh, come on, it's 6. Or rather, it's just 12 different. But if those are millions, it's a big difference, right? Even Kylie thinks it's a big difference if those are millions. So we know that KU and K-tax cannot be the same as WACC. Just can't be the same as WACC. And again, you're going to do this in a problem set where they are the same, and then you're going to talk to me about why you know they can't be. Okay?